Hello and welcome back to another video. In this video, we are going to discuss the next three questions, 5th, 6th and 7th from the October-November 2019 970913, that is pure mathematics 1. And here's the question number 5. The dimensions of a cuboid are x centimeter, 2x centimeter and 4x centimeter as shown in the diagram. You can see it's a cuboid. Show that the surface area s centimeter square and the volume v centimeter cube are connected by the relation this. So first of all, we'll find what is the s here, surface area, and we know the surface area of cuboid is going to be 2 times lb, bh and hl. So it is 2 times lb, that is 2x into 4x plus 2x into x plus x into 4x. So it becomes 8x square, 2x square and 4x square. So 8 to 10 to 10, 14 and 14 to the 28 x square. So this is S, and volume, we know volume in the cuboid is L into B into H. So it is 4x into 2x into x. So it is 8x cube. It is 8x cube. Now we need to prove this relation because we are going to show that it is related by this. So we'll start with the right hand side, that is 7v to the power 2 by 3, and we'll prove that it is exactly same as s. So it is 7v is 8x cube raised to the power 2 by 3. It is 7 into 8 to the power 1 by 3 is going to be 2. So it is 2 square into x cube to the power 1 by 3 is x and 2, so it is x square. So 4 7 is 28 x square, and which is same as s, and hence it means s is equal to 7v to the power 2 by 3. So I hope it is clear. That is what we need to prove. Let's do the second part of it. Here's the second part. When the volume of the cuboid is 1000 centimeter cube, the surface area is increasing. Means when V is equal to 1000 centimeter cube, ds over dt, this surface area is increasing with the rate of 2 centimeter square per second. Find the rate of increase of the volume at that instant. It means we need to find dv over dt. So anyway, we have dv, we have a relation in v and s by s is equal to 7v to the power 2 by 3. So we can use the chain rule in this case, like dv over ds into ds over dt, and we can find dv over ds, and ds over dt is already given as 2, so we can replace it, substitute in this, and we can get the dv over dt, that is the increase of the volume at that instant. And from here we can see what is ds over dt. So we are going to find ds over dt and we'll replace it here, so that in the reciprocal of that, it is going to be 7 into the power will come in the multiplication and will reduce one power, power by 1, that is 2 by 3 minus 1, that is minus 1 by 3. So it becomes 14 over 3 v to the power minus 1 by 3. So that is the ds over dt. So if we'll replace, substitute here, it would become dv over ds, and that is going to be 3 over 14, and it was v to the power minus 1 by 3, so we can take it as 1 upon v to the power 1 by 3. So that would be coming in the numerator here, and it is 1 by 3 into 2. And we know we need to find the rate of increase at that instant. It means at that place v is 1000. So it is going to be dv over dt as 3 2, and this is got cancelled. It is 3 by 7 into 1000 1 by 3, and 1000 cube is cube root of 1000 is 10. It becomes 30 over 7. So that is the rate of increase of the volume at this instance. We can write the rate of increase of the volume is 30 over 7 centimeter cube. It is going to be centimeter cube per second. I hope it is clear. Let's do the sixth question. The question number 6. a line has equation y is equal to 3x minus 2k, and a curve has equation y is equal to x square minus kx plus 2, where k is a constant. Find the set of values of k for which the line and curve meet. So whenever the two curves lines or two curves or two lines are meeting, it means we are going to equate them. So it means we will equate both the equations to get the intersection points. And that is also, there's another condition is they intersect, they meet at two distinct points. So if we equate them and we get the quadratic equation, then we'll find the discriminant, where we'll find the value of k for which the discriminant is greater than 0, because we know when discriminant is greater than 0, then only the solution of quadratic equations are two distinct real values. So since they meet, it means 3kx minus 2k should be equal to x square minus kx plus 2. So let's take everything to let's write it in the from this left hand side and transfer everything to the other side. So it is x square minus kx, this is minus 3kx plus 2 already, this will come here, it would become minus plus 2k, and this will become 0, so I have written here. So for the intersection point, for this, like, roots of this equation will be the intersection points, but we don't require to find the intersection points, we only need to find the values of k for which we get the two distinct points, two distinct roots. So for two distinct roots, d should be greater than 0, or b square, that is minus 4 square 4x minus 4k square, that is 16k square, minus 4 times a into c, c is 2 into 2 plus 2k, so it is 2 plus 2k, that should be greater than 0. Or we can solve it as 6k square minus 8k minus 8 greater than 0, or we can divide by everywhere, divide by 2 8, we'll get 2k square minus k minus 1 greater than 0, and we can factorize it, we can see it is 2k square minus k minus 1, so we can write it as 2k square minus 2k plus k minus 1 greater than 0, and we'll take the 2k common from the first two terms and the last two terms, and we will get it as, in one bracket we'll get 2k plus 1, in another bracket we will get it as k minus 1. So the roots of this equation would be, the roots of this equation is going to be minus 1 by 2 and 1, and we know that we require the part which is more than 0, that is above part, this part. So for that, x values, that is k values, will be these two. It means k should be less than minus 1 by 2, or k should be greater than 1. So if these two conditions follows, then we will get the two distinct points, so that these are the two values of k, we can say, or we have the set of values of k. So I hope it is clear. Let's do the second part of it. Second part is for each of two particular values of k. So for, it means for k is equal to 1 and minus 1 by 2, the line was actually, it was y is equal to 3kx minus 2k to the curve, show that these two tangents meet on the axis. So this is a tangent, line is a tangent, and we need to prove that they meet at x-axis. So first of all, let's find the two tangent, that is y at k is equal to 1, so it is 3x minus 2, and y is equal to minus 3 by 2 x minus plus, and 2 into 1 by 2 is 1. So these are the two tangent, to the curve. Now we need to show that these two tangents meet on the x-axis. So first of all, we'll find the, again this is meeting things, so again we are going to equate them to get the values of x and y. So we can see this, if we equate them, it is going to be 3x minus 2 is equal to minus 3 by 2 x plus 1, and it means 3 minus 3 by 2, that is 3 plus 3 by 2. 3 2 just 6 plus 3 9 by 2. X is equal to this minus 2 plus 1 become this minus 2 will go here, it is plus 2 plus 1, that is 3, and we got it as x is equal to 6 over 9, that is 2 by 3. So x value is 2 by 3. Now we need to prove that they meet on the x-axis. So that is the intersection point, that is the point where they intersect. So x value is 2 by 3, we'll put it in this to get the y-intercept. So y at 2 by 3 for this tangent is going to be 3 into 2 by 3 minus 2, of course that is 0. And for another line, y is equal to minus 3 by 2 into 2 by 3 plus 1. These two got cancelled, we got 1 minus 1, so it is again 0. So it means they meet at the tangents meet on the x-axis, because the intersection points are going to be 2 by 3 0 and 2 by 3 0, so they are meeting on the y-axis. Let's do the seventh question. This is the seventh question, first part. Show that the equation 3 cos power 4 theta plus 4 sine square theta minus 3 is equals 0 can be expressed as 3x squared minus 4x plus 1 is equal to 0, where x is equal to cos square theta. So we can see it is cos square theta. So everywhere we only require cos square theta. So, and we know in the AS level we have one identity where the sine square and cos square got connected. So it becomes 3 times cos power 4 theta plus 4 into 1 minus cos square theta. That is the identity which connects sine square and cos square theta, and minus 3 is equal to 0, or we can write it as 3 times cos power 4 theta plus 4 minus 4 cos square theta minus 3 is equal to 0. Let's collect them together. We can write it as 3 times, and I'll write cos square theta and whole square because it will give 4, and minus 4 cos square theta, and this plus 4 minus 3 is plus 1 is equal to 0. So if we substitute x is equal to cos square theta, then we can write it as 3 times x square minus 4x plus 1 is equal to 0. So that's we need to prove. That's it. Let's do the second part of this question. Here's the second part. Hence solve the equation 3 cos power 4 theta plus 4 sine square theta minus 3 is equal to 0. So from the first part we have seen if x is equal to cos square theta, then in that case this equation can be written as 3 times x square minus 4x plus 1 is equal to 0, and the theta is between 0 and 180 degree here. So first of all we'll solve this quadratic equation to get the roots. So it is like 3x square minus 3x minus x plus 1. We can split the middle term and we'll get it as 3x common and x minus 1 common from the last two terms, and we'll get this is equal to 0. Or we can write it as x minus 1 and 3x minus 1 is equal to 0. So we got the roots of this quadratic equation, that is 1 and 1 by 3. So from here we'll substitute back and we'll get cos square theta as 1 and cos square theta as 1 by 3. So from here we got cos theta as plus minus 1 because square, so plus minus 1, and from here we'll get cos theta as plus minus 1 over root 3. So from here we get theta is equal to cos inverse of plus 1. Cos inverse of plus 1 is 0 degree, and cos inverse of minus 1. So cos inverse of minus 1 is 180 degree. From calculator also we can calculate, and from here since we know that we don't have the proper values for this, so we'll use the calculator, and from here we'll get theta is equal to first of all cos inverse of 1 over root 3, and next is cos inverse of minus 1 over root 3. And from here we can see the next value for 0 is 360, and for 180 it is going to be 180 again, and then 360 plus 180. So we don't have to go ahead because we only have the theta between 0 to 180. So from here, for these two, we'll get the values from the calculator, and the value is, for positive 1 over root 3 is 54.735, so 54.7 degree. And for this negative 1 by root 3, it is going to be 125.26, so it is 3 degree. So altogether the solutions for these are 0 degree, 54.7 degree, 125.3 degree, and 180 degree. These are the solution of this equation between 0 and 180 degree. So that's it for this video. We'll discuss the last few questions in the next video. Till then, thank you so much.